Lesson 13.6. Apply measures of center and variability. Essential question. What do measures of center and variability indicate about a data set? Unlock the problem. Julia is collecting data on her favorite sports team for a report. The table shows the median and interquartile range of the heights of the players on her favorite baseball and basketball teams. How do the heights of the two teams compare? So we're looking at this set of data in this graphic organizer and table off to the side. It says compare the medians and interquartile ranges. So here's the median, and interquartile ranges. So the median, we're looking at this column. Interquartile range, we're looking at the second column. So the median of the blank player's heights is blank inches greater. So what's the difference between the basketball team and the baseball team? We do 78 minus 70 is 8. So the median of the basketball players' heights is 8 inches greater than the median of the baseball player's height. Interquartile range. The interquartile range of the baseball team is, now we're looking here, the baseball team is bigger, so 6 minus 4 is 2. The interquartile range of the baseball team is greater than the interquartile range of the basketball team, so the height of the baseball players vary more than the heights of the basketball team. So the players on the basketball team are typically taller than the players on the baseball team. And the height of the baseball team vary more than those of the basketball team. So the interquartile range is going to be your difference there. Okay, number 1. Julia randomly picks one player from the basketball team and one player from the baseball team. Given data in the table, can you say that the basketball player will definitely be taller than the baseball player? Explain your reasoning. You cannot definitely say that the basketball player will be taller than the baseball player. That could be an assumption you might make, but you cannot make that statement as a fact based on just this chart up here. So the median the median height of the basketball players is greater than the median height of the baseball players. But that does not mean every basketball player is taller than every baseball player. Example. Compare the means and ranges of the two data sets. Kamira and Joey sold t-shirts during lunch to raise money for a charity. The table shows the number of t-shirts each student sold each day for 2 weeks. Find the mean and range of each data set and use these measures to compare the data. Step 1. Find the mean of each data set. So the first thing we need to do is we need to look at each section to see what they are labeled, to know where we need to look over on the table. So we're going to start with Kamira. So we need to add all of the numbers together. So I'm just going to go ahead and put them in order, so then I have them in order. So let's start from smallest to largest. So there's 1, another 1, and another 1. So there's 3 ones. There's a 2. There's 2 3s, 3 3s, a 4, and 3 5s. Okay, that's her data set. Okay, now we add up all of these numbers together. So 5 plus 5 plus 5 is 15, plus 4 is 19. I'm looking backwards. So then 3 and 3 is 6. That's 25. Plus 2 is 27. Plus 3 more is 30. So my total is 30. I'm putting that on the top. Now I need to go back and I need to count how many numbers are in the data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have 10 numbers in the data set. 30 divided by 10 is 3. So the mean for the first set is 3. Okay, now the next thing you're going to do is you're going to look at the second set of data. So you're going to look at the second part, which is next to Joey. So this is the t-shirts that he sold. So let's do the same thing. We're going to start from the smallest to the largest. There's 2 zeros, 0, 0. There's a 1, there's a 1, there's 2 1s, 2 2s, 2 3, 2 4s, and a 13. Okay, now we need to add all of those up. So again, I'm going to start with the largest. So 13, and I know 4 plus 4 together, that's 8. And then 3. Okay, now I'm going to add, so 8, 9, 10, 11, 12, 13, 14. Okay, that's 24. We've added 13, 4, 4, and 3 so far. So 2 and 2 is 4, it's 28. Plus 2 more, that's 30. So my answer here is also 30 divided by 10. And then my answer here is also 3. Step 2. Find the range of each data set. Okay, so we need to find the range of each data set. So we're looking at Chimera first. Okay, so we're looking at the largest number, which is 5. Smallest number is 1. So 5 minus 1 is 4. For the range for Chimera. And then the range for Joey, the largest is 13. Smallest is 0. So your range here is 13. And then you're going to compare the mean and range. Compare the mean and range. The mean of Joey's sale is the same as the mean of Chimera's sale. The range of Joey's sale is greater than the range of Chimera's sale. So the typical number of shirts Joey sold each day was the same as the typical number of shirts Chimera sold. However, since the range of Joey's data was greater than Chimera's, the number of shirts Joey sold varied more. So that means the difference was more from day to day than the number of shirts Chimera sold. Number 2. Explain which measure of center would better describe Joey's data set, and explain. So the median. The median is 2, because we're going to look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 4 on this side, 4 on this side. These are 2 in the middle. 2 plus 2 is 4. Divided by 2 equals 2. So the mean is 2. That's how I got that number, which is close to the number of t-shirts he sold in one day. Share and show. Number 1. Zoe collected data on the number of points her favorite basketball players scored in several games. Use the information in the table to compare the data. So we're looking in this table. Looking at this table. The mean of the players, so the mean of player 1, so we're looking right here. The mean of player 1's points is blank than the mean of player 2. So we're looking at both of these numbers for mean. So it is less than. 24 is smaller than 33. the number of player 2. The interquartile range, so now we're looking here. The interquartile range of player 1's points is less than the interquartile range of player 2's points. So player 2 typically scores more points than player 1, but player 2 scores typically vary more than player 1 scores. Number 2, Mark collected data on the weights of puppies at 2 animal shelters. Find the median and range of each data set and use these measures to compare the data. Okay, so the first thing we need to do, let's find the median and find the range. So the range for shelter A would be 0. The range for shelter B would be 13 minus 4, so that would be 9. So these are the ranges. Okay, now the median is going to be your middle number. So 1, 2, 3, 4, 5, 6, 7. 12 is our middle number here. 1, 2, 3, 4, 5, 6, 7. 11 is our middle number there, so our median. So the median for A is 12. Shelter B is 11. So now we can look at these numbers. The ranges are 0 for shelter A, but the median is 12. The range for shelter B is 9, but the median is 11. So shelter A the median is 7 pounds. Range is okay, sorry, I made a mistake there because I thought these numbers were already in order and they were not. So first thing you need to do is look at shelter A, look at the numbers, and you need to put them in order from smallest to greatest, which is what I did right here. So I have 5, 7, 7, 7, 10, 12, and 15. So after they are put in order, you need to choose the middle number, which is 7. So the median is 7 pounds. The range, now we're going to do 15 minus 5 for the range, which we know is 10. Okay? Now we're going to do the same thing for shelter B. So let's do this. B, and then 4 is your smallest number, 4, 5, another 5, 11, 11, 13, and 15. Okay, I used all those numbers, and I just kind of cross them out as I go. So all of them are used. Okay, now your highest number is 15, your lowest number is 9, which means your range is going to be 11. So, and then your middle number here is going to be 11. Okay, so for shelter B, your median is 11, range is also 11. So there is about the same variation within this 2 sets of data, but the typical weight of the puppy in shelter B is greater. So the weight of puppies in shelter B are bigger, larger, or more. We would say are more. That sounds better. And then the typical weight of the puppies in shelter A are smaller. So either one, if you want to say the weight of the puppies in shelter B are larger, or the weight of puppies in shelter A are smaller. Each one or either one of those would be correct.